In this video, we're going to talk a little bit about quadratic functions, which was part of the topic in lesson 12. Quadratic functions are useful in the real world to think about the path of a projectile, such as a football, a baseball, a basketball, a shot put, an arrow, even a bullet, or a rocket. Also, braking distances of vehicles, the maximum area of an enclosed space, and even pricing items within the business world. The formal definition of a quadratic function says let a, b, and c be real numbers. So basically we can use any number we can think of within our number system with a not equal to 0. Then the function f of x equals ax squared plus bx plus c is called a quadratic function. One of the things that makes it a quadratic is that your highest exponent is 2. Visually, the graph of a quadratic function is a U-shaped curve called a parabola. The domain is going to be all real numbers. One of the main characteristics of a quadratic function is that it is symmetric. If you could imagine a line running through the center of the graph, and then fold it on that particular line, then you couldn't tell the left side from the right side. So there's this imaginary dotted line here, if you want to think about it that way, that you could fold across and you wouldn't be able to tell the left side from the right side, and that's called the axis of symmetry. This low point where the graph kind of turns, bottoms out, if you will, is called the vertex. And that's one of the key points on a parabola. The letter A in the formula, the value in front of the x squared term, helps us to get some information about whether the parabola is going to be opening upward or opening downward. It also gives us some insight in whether there's going to be a stretch or a compression vertically. And you can read through that information. The main thing I want to focus on, though, is quadratic functions are written in various forms, and sometimes one form is better than another depending on what information is needed. Your text calls it the standard form, and it's typically in the form f of x equals a times the quantity x minus h squared plus k. In this form, we can very easily identify the vertex, that key point where it's changing direction. It also gives us the horizontal shift and the vertical shift. We can readily identify the vertex and the axis of symmetry. The other form, which actually is more common, is the general form, which is ax squared plus bx plus c. And oftentimes you're asked to convert from the general form to the standard form, and the process for doing that is called to complete the square. Now, you may have forgotten that process. It's at times can be a lengthy one. So we basically begin, we want to remember this is A is in front of the squared term, B is is in front of the x, and C is the constant. So there's a couple of ways to do this. With completing the square, you want to move C to the other side of the equal. Okay, so I'm going to do that first. So I would have 2x squared plus 8x equals, and when I move the plus 6 to the other side, it becomes negative 6. So I basically have all of the variables on the left and the constant, or the c, on the right side. Then I notice in this particular scenario that I have a common factor of 2, so I'm going to factor it out. So I have x squared plus 4x equals negative 6. Now, what I'm trying to do is basically force the expression inside the parentheses on the left side to be a perfect square. Once I've got it set up in this manner, we're going to take half of b and square it. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 inside the parentheses, which forces that expression to be a perfect square. But now be careful. We added a 4 inside the parentheses, which has to be multiplied times this 2, which really is 8. So I've added 8 to the left side. So I also have to add 8 to the right side. So then if I work on doing the factoring, I have 2 times x plus 2 times x plus 2, or 2 times x plus 2 squared, and that equals positive 2. And then to get my final answer, I'm going to put everything back together on the left side. So I'm going to subtract 2, subtract 2. So I end up with 2 times x plus 2 squared minus 2 equals 0. So that basically at this point, I know that A is 2, which means my parabola is going to open upward because it's positive, and it will be vertically stretched. The H is negative 2, and K is negative 2. So my vertex, the low point on my curve, is going to occur at negative 2, negative 2. Okay, so the main reason for converting from the general form to the standard form is so that you can readily identify that vertex. There are other ways for identifying the vertex. In my opinion, the easier way for finding that vertex is you can use a formula that really is derived from completing the square. If I weren't asked to convert it to the form, the vertex form or the standard form, we could find the vertex simply by using the formula. The h coordinate is the opposite of b over 2a, and the k is found by substituting h back into the problem. And I'll show you how to do that on some of the test review questions. So let's look at one other example, just so you'll have another one to look at besides the one that's on the actual quiz. This one is f of x equals negative x plus 2x plus 3. And again, the first thing I want to do is begin by moving the constant. In this case, remember that a is the number in front of the x squared, b is in front of the x, and c is the constant. So I would have negative x squared plus 2x equals, and when you move the 3 to the other side, you change the sign. Then I notice that I have a negative 1. I don't really care for the negative on the square, so I'm going to factor out the negative 1. I'm left with x squared minus 2x equals negative 3. Then we start the squaring process. We take half of b, so half of 2 is 1. 1 squared is 1. So I've added 1 inside the parentheses, or really I've added negative 1. So if I've added negative 1 to the left, I have to add negative 1 to the right. So if I factor, I have negative 1 times x minus 1 times x minus 1 equals negative 4. Putting it kind of back together, I have negative 1 x minus 1 squared equals negative 4. Put everything back together on the left side. So I'm going to add 4, add 4. So we have negative 1 x minus 1 squared plus 4. Again, once it's in that form, I can tell you that the A is -1, so my parabola is going to be turned downward. Okay, they're going to cause, the -1 causes a reflection on the x-axis. The h coordinate is 1. The k coordinate is 4. So I would have the vertex for my parabola would be 1, 4.